Assalamualaikum and very good afternoon. Hi everyone, my name is Madam Siti Azwani. I will be teaching the basic laboratory skill subject for physics part. Okay, today you have first topic basic graph plotting. Okay, before we learn detail about this topic, basic graph plotting, let's look the formative assessment or the coursework mark. Okay, actually for this part, you can go through, okay, you can got this explanation, you got this detail in the module handbook. But okay, today I just give a super briefly briefing about this part. Okay, for the coursework mark. Okay, this is for the physics part. Okay, for physics part, you have a basic graph plotting, the first topic, okay, and then you have assignment, okay. After you finish your basic graph plotting lecture today, okay, you need to do your assignment, okay, means you need to plot 4 graph, okay, then you need to submit. The mark is equal to 20 marks. Okay, second, you have the experiment 4, okay, which is the topic is the physical measurement with error analysis. Okay, after you finish your experiment, you need to write the report, okay, which is the practical report, okay, and then you need to submit. The mark is 20 marks. Okay, third, you have also the practical, the experiment, the practical. The topic is the Hooke's law. Okay, after you finish the experiment, the practical of the Hooke's law, you need to write the practical report. Then you need to submit. The mark is 20 marks. Okay, next, quizzes. Okay, you have at the end of semester, after finish all the syllabus of the topic, okay, after the revision day, in revision week, you have an online quiz. It's more to revision actually for this online quiz. You have all part, which is you have a lab safety, you have a biology part, you have a chemistry part, you have a physics part. The total of your online quiz is the 5%. Okay, and final examination for physics, which is section D, okay, you have 15%. Okay, is it okay or not? Okay, so physics, you have a basic graph plotting, you have a physical measurement with the error analysis, and then you have a Hooke's law. You have one assignment. Okay, so you need to submit the assignment. You have 4 graph. Next, you have a practical report, and third also you have a practical report, means you have 2 practical report you need to submit and 1 assignment, which is 4 graph. Okay, and then you need to do your online quiz and your for final exam, okay, which is under section D. Okay, if you refer here for the coursework or the formative assessment, 35% practical, okay, means the practical and assignment for all part, biology, chemistry, and physics. The total is 35%. Okay, and then quiz, you have 5%. So the total of the coursework or the formative assessment is equal to 40%. Okay, and then final you have 60%. 60%, okay, is come from your from the section A, section B, section C, and section D. Each section is equal to 5%. Okay, understand or not? Okay, the rest part, which is the biology part and the chemistry part, will be explained um, your lecturer, your respective lecturer will explain about that part, the chemistry and also the biology part. Okay, so first you have a purpose of the laboratory. Why you need to go to the laboratory? Why you need to have your laboratory? Okay, purpose of the laboratory. Okay, why you need to learn the basic laboratory skill here. Okay, students to be able to carry out experiment in physics 1 and physics 2. Okay, in physics 1 sem 2, in physics 2 sem 3, you have a practical. Okay, so you need to have the basic how to carry out the experiment. Okay, so when you go for the physics 1 and you go to physics 2, you are very familiar with that, the basic part. Okay, next students should to expose to the basic skill to observe, tabulate, and make a conclusion, okay, on physics concept. Okay, this is the basic laboratory skill. Okay, you will learn how to observe, how to tabulate, how to make a conclusion. Okay, how to write your data in the table. Okay, how to write the discussion, how to analyze the result. Okay, and then at the end of the experiment, at the end of the practical, how to write the conclusion. Okay, it is obey or is not obey with the concept in physics. Okay, is it you got the value, is it the same with the constant value or not? Example, you have experiment, okay, to calculate the acceleration due to the gravity. Okay, the constant value of the acceleration due to the gravity is 9.81. Okay, so you need to do your experiment, so you must have a skill how to observe, how to write the data, how to discuss, okay, the result, and then at the end of your experiment you want to make a conclusion from the experiment. Okay, the value, okay, is it the same or not with the constant value? You got the value in your experiment, example you got 10. Okay, so 10 is almost the same. Okay, is same with the acceleration due to the gravity. Okay, you have a plus minus, and then we can say it's acceptable, it's okay. Okay, next, students should be able to plot the right graph. Yes. Okay, most of the experiment in physics 1 and physics 2, you have a graph. You need to plot the graph. Okay, you need to analyze your value, the information from the graph. Okay, so first you need to write the you need to plot the right graph. If your graph is wrong, then the rest part wrong. At the end, if you want to write the conclusion also wrong. Okay, next, students should be able to use the equipment and measurement in a right method. So in the basic laboratory skill, you need to know how to use the equipment, okay, or how to measure in the right method. Example, you want to measure the diameter of your marble by using the micrometer screw gauge. You need to know how to read the reading, and then you need to consider also the error. Okay, so you may use this the skill for the physics 1 or the physics 2. Okay, next, preparation for the laboratory. Okay, this is for you if you want to go to the lab. Okay, before experiment, read the procedure regarding to the experiment. Okay, the lab manual we already uploaded in the LMS, so you need to print out. Okay, you need to read the procedure, the method, okay, regarding to the practice, regarding the experiment, and spend the sufficient time preparing for the experiment before coming to laboratory. Okay, so you can imagine, oh, today I need to do this one. Okay, this is the method. First I need to do this thing. Second, I need to write or to measure this thing. Okay, after experiment, write up the experiment report. At the end of the lab, yes, you need to write the practical report, the experiment report. Okay, each laboratory bench must return to a net. You need to clear everything on your table. Okay, third, turn off all source of the electricity, water, and the gas. Sometimes you may have a practical, you need to connect with the power supply. Okay, so connect with the source of the electricity. Okay, and then connect with the other things, voltmeter, ammeter of the resistor. Okay, after you finish your after you finish your practical, the experiment, you need to turn off all the source of the electricity. Okay, it's very important. This is one of the rules and the regulation during the laboratory. Okay, during in the lab. Okay, next, bring to each laboratory session, okay, a pocket calculator. This is the physics subject. Okay, this is the physics part. You have a part which is you need to calculate. Okay, find the final value. Okay, so you must have the calculator to calculate the value. Okay, to solve your problems. Okay, a part of the graph paper, yes, most of the experiment, the practical in the physics 1 and physics and also the basic lab 3. Also, you have a experiment in the basic lab 3. You have to plot the data. Okay, you need to find some of information, example the slope. Okay, from your graph. Okay, so that you need to plot the graph on your graph paper. Okay, next, long ruler. Okay, because you want to draw a line. Okay, so you need using a ruler to for a straight line. Okay, so it's very important for you to bring a long ruler. Stapler, eraser, sharp pencil to be, because you need to draw your you need to draw the line of on your graph paper. Okay. Next, recorded data. Okay, provide accurate information. The information must be accurate. Okay, number of decimal places are recorded. Okay, let's say if you decide 2 decimal places. Okay, so all of data must decimal places are recorded. Okay, the data must be reasonable for each reading. Okay, example here, you have a experiment cooling system. Okay, you need to record the times, you need to record the temperature. Okay, start. Okay, you start your stopwatch, record the time, and then what happened, you record the temperature reduce, okay, from the higher temperature to the lower temperature. Okay, so your data must be reasonable. Okay, when your time increase, your temperature should be decreased. Okay, please recheck if you got time increase but your temperature, sorry, the temperature decrease but your temperature is increased. Okay, the process data should also have the same number of decimal places. Here, the same number. If you set 3 decimal, the rest also 3 decimal. Okay, if you got so many number, you can round up to 3 decimal places or 2 decimal places. Okay, graph plotting. Okay, a graph is the clearest way to represent the relationship between the quantities. Okay, example, the quantities you have length, time of current, okay, of interest, or you want to show the relationship between this variable to another variable. Okay, between the one quantity to another quantities. Okay, or you want to see the relationship between the voltage versus the current. Okay, it's used to determine the average value from a set of reading. Yes, sometimes you have a lot of data. Okay, so you need how to see how to find the average value. So you need to plot the graph, so then you can get the average value. Okay, next, when plotting a graph, the following should be known. Okay, first, name the graph. The title of your graph, you need to write the title of your graph on the top of your graph paper. You must have the title. Example, voltage versus the current. The relationship between the voltage and the current. Okay, you must have the title or the name of the graph. Okay, if let's say if you are forgot to write the title or the name the graph in your final exam, okay, I will deduct your marks. Okay, the name, the title of your graph got marks. Okay, label each axis with the unit shown. Okay, with the unit. Okay, y and x axis. Okay, let's look the example here. Okay, example here. This is the title of your graph, the graph voltage versus current. Okay, and then axis here, you have y axis, you have x axis. Your y axis is the voltage, the quantity is the voltage, and then you have a unit inside the bracket here. Okay, here also you have a current in the x axis. Okay, so label each axis with the unit shown. Okay, third, choose a suitable scale in order to make full use of the graph paper. Graph should usually be at least 3/4 a page in size. Okay, don't draw your graph very small. Okay, in the graph paper, your graph should at least 3 or more than half. Okay, at least 3/4 a graph size. Okay, don't draw a small size. Okay, then choose a suitable scale. Okay, to make, okay, to in order to make full, okay, use of the graph paper. Next, mark prominent division on each scale with the appropriate number. Okay, example here. So your scale starting from 0, okay, then you have 0 0.4, 0 0.8, 1.2, 1.6, 2.0. So it depends so on your data. So you need to choose the appropriate, okay, division on each scale with the appropriate numbers. Okay, start the division on each axis from the origin point 0, 0, and if it is not possible, start with the nearest data to plot has origin. Okay, usually you use the origin or start the division, okay, on each scale from origin 0, 0. But if it's difficult for you, okay, you can start your scale not from 0, 0, from the nearest value. Example here, yes, you have example here. Okay, for the y axis here, the scale is not start from 0. Okay, from the nearest number, which is you have a 60. Okay, so what you need to do is you need to put zigzag here. Okay, to show that you start from the nearest number, not 0 on the y-axis. Okay, but the x-axis you start from 0. So 0, 1, 2, 3, 4, 5, 6. Okay, but here it's like you jump, okay, to the nearest number. I think this is because of most of the data is the range is 60 to 100. Okay, you don't have a data less than 60, below than 60. Okay, just you want to focus on that part here. That's why you start from the nearest, so it's clear for you to see the pattern, okay, of your graph. Okay, is it okay or not? Okay, next, plot the point with the appropriate symbol clearly, such as crosses X. Avoid marking such point with a minute dots, which might be covered by the line drawn through them. So when you want to plot the point, use the cross, the symbol here. Okay, use the cross symbol. Okay, don't use the dot because it might be covered by the line drawn through them, so it's difficult for you, okay, to find the best fit line. Okay, next, draw a best straight line or the best smooth curve through plotted points. Okay, make sure that the number of points on each side of the line are roughly the same. Okay, the most important for the basic plotting graph is you need to draw a best straight line. Okay, if you have a curve graph, you need to draw the best, okay, smooth curve graph. Okay, so next I will show you how to draw the best straight line. Okay, and also I will show you the example, okay, for the best straight line and the best smooth curve. Okay, if the graph is a curve, do not simply join one point to another point, but draw a smooth curve through the point. Observe the figure below on how a line is drawn. Okay, this one is for the curve graph. Okay, when you want to join the point, one point to another point, okay, don't simply to join one point by using the ruler. You cannot use the ruler, okay, to join the point for the curve graph. Okay, draw freehand for a curve graph. For the line, okay, for the straight line, yes, you need to draw by using a ruler, but not for the curve graph. Okay, So here, let's use example. When the plotting a graph, the plotting should be not, okay. So this is the wrong. Why wrong? This is not the line of best fit line, okay. But this one, this is the best fit, okay. Best line is fit, okay. How about the curve graph? This one is not the best smooth curve, but this one, yes, the correct smooth curve graph, okay. So example here, I have example one, best line fit, okay. So you can see here how to draw a line of best fit, okay. So draw a line of best fit using a ruler for a straight line graph, okay. Example 2, okay, example 2 here also you start from 0, okay. Here line of best fit, okay, actually you need to draw in the middle, okay, between the data here, okay. Example 3 here, okay, luckily if you got this side of your data, okay, it's okay, you just straight draw from 0 from the origin here, okay, and then you got the best line fit. Okay, so here you can see here using the cross to plot your data, don't use the dot, okay. Next, okay, example for baseline fit here, okay, you have one outliner, okay. So you have, it's like one value is what we call inconsistent point, okay. This is what we call inconsistent point, okay. If you want to draw the line of best fit, okay, you can ignore this point, okay. You can decide to ignore in the consistent point, it's okay, okay. So this is the become your best fit line. Okay, actually for this one, you use your apparatus to check this measurement again. Okay, maybe you got some error. Okay, you can recheck by repeat the experiment or check, okay, this measurement again. Or you have used another method, okay, how to find the best line fit. Okay, example here, draw the maximum. Okay, you can refer to the red dotted here. This is to refer to the maximum because you have a maximum point here. Okay, so you need to draw a line pass through the maximum point here. It become the maximum line, and then the minimum. Okay, if you refer all the point here, okay, you have a minimum point here. So you need to draw along to the minimum, okay, point showing by the blue line here, okay. So the middle here is become the best line fit, okay, the best line fit. Is it okay? Okay, next example 6 here. Okay, here you can start the scale for your y-axis here with the nearest number, but don't forget to put the zigzag here. Okay, here you can see, okay, don't forget to write the title, the time spent, and the report grades, okay, the label of your axis, okay, and then draw the baseline fit, okay. Make sure it's like in balance, okay, like you have to up, to down, for down, okay. Make sure there is a best fit line, okay. Next, example 7 here, okay. I will show you how to draw your plotting the data point, drawing a line of the best fit, and then you may have a question you need to answer. Okay, example here, you have a size, okay, and then you have a mass, the size of the shoe size, okay, starting from 5, maximum is 12, okay, and then you want to see the relationship between the size of the shoe size with the mass, people mass. Okay, so you have a data of the size, and then you have a data of your mass. Okay, and then draw the scale here. Okay, y is it you have a mass, x is it you have a shoe size. Okay, so 5 65, the 5 x y is 65. Okay, next 12, you have a 12 x component, and then y you have 97, and then next continue to plot the graph. Okay, 7 98. Okay, here you can start from the nearest number. Okay, for the y and x axis, y and x axis also acceptable. Okay, and then after you draw all the point, okay, and then plot the, and then draw a line of best fit using a ruler. Okay, this is for a straight line graph. Okay, so here you have your line of best fit. Okay, draw a line of best fit and comment of the correlation. You have a positive, what we call positive graph. Okay, use your line of the best fit to estimate. Okay, you can use the line. Okay, you may have a question. The mass of a man with the shoe size 10.5. Okay, so from the graph here, so you have 10.5 here, and then from this point you can see what is the value of the mass, okay, of a man. If he got the shoes size is 10.5, which is 87. Okay, so you use some information after you plot the graph. You get the some information, okay, from your graph. Okay, next, the shoe size of a man with a mass of 69, or you want to find. Okay, you have a question. Can you estimate the shoes size of a man when his mass is 69? So here 69. Okay, draw a line here, and then draw a line, go down, and then you find that is size 6. Okay, understand or not? Okay, next, you have a smooth curve. Okay, a smooth curve. So you have here example, you have a lot of the data, a lot of a point. Okay, so you can see the pattern. If you want to draw the smooth curve, it's like this. Okay, it's like in the middle, okay, of all of your data. Next, example 2, you have a cooling system. Okay, temperature in a 5-minute degree. Okay, number of cup. So here you may have one, what we call in a consistent point. You can ignore because you want to draw the smooth curve graph. But you can see here the pattern. Okay, so it's not necessary for you to touch all the point for the smooth curve. Okay, but you can see the pattern here. So draw middle here. Okay, and going up. Is it okay? Next, it goes same with this graph, smooth curve graph also. It's not necessary for you to touch all the point, but you can refer to this point, the pattern, okay, and then draw smooth curve graph. Okay, remember for the curve graph, draw freehand for a curve graph. Don't using a ruler. Okay, this is not the straight line, this is the curve graph. You need to draw freehand. Okay, by the handwriting. Don't use the ruler. Don't simply join one point to another point by using the ruler. Okay, next example, example 4, smooth curve. Okay, curve of the best fit. You can see here. Again, it's not necessary for you to touch all the point. Okay. Okay, next, obtaining information from a graph. Okay, if you refer to after you plotting your graph, okay, so from the graph you can get some of the information, some of the value. Okay, let's look here. Obtaining information from a graph. First, to determine the gradient of a straight line graph. Okay, so from the graph you can calculate the gradient. Okay, the slope of a straight line. Okay, draw a triangle. So the method, okay, how to find the gradient, how to find the slope. Okay, so that the gradient is more accurate. Okay, the draw, you need to draw the triangle as big as possible. Okay, don't draw the small triangle in your graph paper, it's not accurate actually. Okay, so draw a triangle as big as possible so that the gradient, the slope, the is more accurate. Okay. Then get 2 point x1, y1, x2, y2. Okay. Gradient, the formula. Okay. To calculate the gradient, the slope, m, symbol by m for the gradient, the slope is equal to y2 minus y1, x2 minus x1. Okay. Example here. You have a point y2. Okay, you have a y1 here, y2 minus y1. Okay, you have the x2 here. Okay, and then minus the x1 here. So is equal to the gradient, is equal to the slope. Okay, next, the information. Okay, for the gradient, okay, if you go for the physics one, also you have a practical. Okay, the Hooke's law, the gradient. Okay, after you calculate the value gradient, the gradient value, the slope value is equal to the spring constant. Okay, so the information from a graph, okay, is one important, is one of the important part. Okay, you need to consider because it's equal to some of the value which is related to the concept in the physics. Okay, example, or if you have experiment in the uh, physics 1 or the physics 2, the same thing. Okay, or physics 2 you have voltage versus the current, the Ohm's law. Okay, from this from the experiment. Okay, you need to calculate the value of the resistance, how to find the resistance, how to calculate the gradient. Okay, after you plot the graph, you need to find the gradient, you need to find the slope. So the value of your slope, the value of your gradient is equal to the resistance of the wire. So it's very important for you to know how to find the gradient, how to find the slope. But before that, make sure the data is correct, the plotting graph is correct. Okay, the scale also correct. Okay, and also with the correct unit. Okay, next, obtaining information from a graph to determine the y-intercept is the value of the y when x is equal to 0. To determine x-intercept is the value of the x when y is equal to 0. Okay, here is y-intercept, this is the x-intercept. Okay, you have also the experiment of physics 2. Okay, or the physics 1. Okay, find the y-intercept, find the x-intercept. Your y-intercept is equal to the focal length, or y-intercept is equal to the value of your EMF. So the information from the graph is very important and can represent or some of the value and is related to the concept in the physics. Okay. Okay. Example here, the gradient of the straight line. Okay, after you plotting the graph, okay, choose 2 point. Okay, here you have 6, you have a 10, 8. Okay, get 2 point. Okay, and then substitute the value into your formula, 8, y2. Okay, and then y1 you have 6. So 8 minus 6, and then 10. Okay, for the y, for the x2 minus x1, you got 6 here. Okay, so solve the equation, the problems, you got half 0.501 over 2 is equal to the gradient is equal to the slope. How about the y-intercept? You have a y-intercept is equal to 0, which is x is equal to 0. Y is equal to 3, your x is equal to 0. So y-intercept is equal to 3. Okay, is it okay, everyone? Okay. Next, displacement versus time. Okay, so information. Okay, obtaining information from the graph. Example, this is example. Okay, from the given displacement time graph, the stroke rate of the graph is the velocity. So here you have a quantity. Okay, displacement versus the time. Okay, when you plot the graph. Okay, displacement versus the time. Okay, if you calculate the slope, if you calculate the gradient of the graph is equal to the value of the velocity. Okay, the straight line of the graph show that the slope is constant, so it's produce the constant velocity. Is the line is horizontal, no change in displacement, the velocity is 0. When you have a horizontal line, no changes. Okay, no, the slope is equal to 0. Okay, the velocity is equal to 0. Okay, you learn this part detail in the physics 1. This is just example. Okay, example, if you have a displacement versus the time, the graph, okay, you can get the velocity from the gradient from the slope. Okay, so here how the example, okay, how to find the velocity from your graph displacement versus time. Okay, so x2 x1 t2 divide by t2 minus t1. Okay, the change of the displacement divide the change of the time is equal to velocity. Okay, next example, when you have a graph velocity versus time. Okay, the gradient of the velocity time graph give the acceleration of the object. Okay, straight line graph means the acceleration is constant. Okay, if the object move with a constant velocity along the horizon, the acceleration is equal to 0. Example here. Okay, when you have no changes, okay, v versus t, okay, v divided by t, okay, you have a constant, okay, you have a straight line graph, okay, meaning here the acceleration is constant. You have your constant velocity, okay, along the horizontal, so means no gradient, so zero slope, the gradient is equal to 0. Okay, so acceleration is equal to 0. Okay, so gradient of the v versus the time, you have a change of the velocity divided of the change in the time, dv over dt. So you have a gradient or the slope is equal to the acceleration. Okay, also you learn detail this part in the physics 1. Okay, next example, the graph. Okay, you have a displacement, okay, from the velocity versus time, velocity time graph. Okay, here shows that, okay, if you have a velocity versus the time, okay, the area under the velocity time graph is the displacement of the object, the information you can got from your velocity versus time graph. Okay, area, okay, you can calculate area under the velocity time graph. Okay, rectangular. This is the first method. You can divide into two area, rectangle by the red part here, triangle by the blue part here. Okay, and then plus by using the area. Okay, the total area of the triangle. Okay, and the total area of the triangle here. By using the formula here, you got the first area rectangle 20, area of triangle you got 20. So total area 20 meter plus 20 meter you got is equal to 40 meter. Okay, so the area here, okay, 20 plus 20 is equal to 40 meter. is equal to the displacement of the object. When you have a graph, velocity versus time. See, you can get information, okay, obtaining information from the graph. Okay, next, alternative way for the displacement here. Again, when you have a velocity versus the time, you can calculate the area under the graph, which is equal to the displacement. Okay, here you use the trapezium, okay, method or the alternative way, okay, to calculate the area of the area under the graph. Okay, so you have a formula for the trapezium: half time with the height, okay, time with the base 1 plus base 2. This is your height, and then you have a base 1 and then base 2, base 1 plus base 2, time with the height, time with the half. You got the area under the graph, which is equal to the displacement when you have a graph velocity versus the time. See, obtaining the information from the graph. So make sure your graph, you plot right graph. Okay, you need to plot right graph. Okay, next, conclusion from the graph. Okay, you can refer here you want to state the relationship between the y and x term. Okay, so the difference between the two graph here, you can see here. Okay, for the first graph here, first you can say that y is directly proportional. Okay, when you have data, okay, when you have a average increase, the perceived loudness also increase. So y is directly proportional to the x. Okay, positive relationship, or you can say y increase linearly to x. Okay, how about this graph? If you got this side of the graph, what happened? Okay, y decrease, the x also decrease. Y inversely proportional to the x. You can say the relationship between the y and x. Y inversely proportional to the x, or you have a negative. Okay, for the graph here. Okay, is it okay or not? You can conclude from the graph. Is it directly proportional or inversely proportional? Okay, increase linearly or it's not decrease, and y x decrease, the y also decrease. Okay, is it okay for the plotting, basic plotting graph? Okay, you need to write the graph. Okay, the title, the label of your axis, the unit of your label. Okay, the scale also must be correct, and then plot by using the cross, okay, not dot, on your graph paper for your point, and then draw a line of base speed using a ruler for a straight line, and draw freehand for a curved graph. Okay, and then if you have a question to calculate the uh, slot, the gradient, make sure draw the triangle as big as possible on your graph paper. Okay, and then substitute the value, the point, okay, in your formula to calculate the slope, to calculate the gradient. Also, it's the same with the intercept. Make sure you extend the line on the y-axis or the x-axis if you want to find the y-intercept or the x-intercept. Okay, and then you need to refer back to your gradient, the graph, okay, to conclude the relationship, to see the relationship between the one quantity to another quantity, one variable to another variable. Okay, just this one just want to remind you, okay, for the laboratory safety rule. Okay, if you do your practical, if you do your experiment, you need to follow the rule and the regulation in the laboratory. Okay, laboratory safety rule. Okay, perform laboratory work only when the lecturer or the lab technology is present. You are not allowed to do your experiment alone or without the lecturer or without the lab technologists. Okay, second, students are compulsory to wear laboratory coat all the time. That is very important. Okay, you need to wear your lab coat. Okay, all the time. Then so that you don't please don't forget to bring your lab coat when you have a practical on that day. Okay, if you forget to bring your lab coat, it's okay, you can go to our office, okay, level 6 in the main block to borrow the laboratory coat. Okay, but you need to pay 5 ringgit. Okay. Next, dress in the proper attire when conducting in the laboratory. Okay, please don't use the short pant, don't use the skirt when you want to conduct, when you want to do your experiment. Long hair must tie back and the glitch everything must be secure. Okay, next, shoes must completely cover the foot. No sandal allowed on lab days. But if you have a problem, like you have an injured or something, please tell to your lecturer first. Okay, let them know about you. Okay, next, do not eat food, drink beverage or the chewing gum in the laboratory, please. Okay, do not smoke in the laboratory. Okay, next, clear your bench top of all unnecessary material. Okay, especially when you finish your practical, you need to return back all the apparatus, all the equipment, okay, in the correct place. Okay, next, avoid unnecessary movement and talk in the laboratory. Please don't play around. Okay, you need to do your experiment. You need to do your experiment. You need to show your teamwork. You have a mark. Okay, when you go to the practical, you have a you need after you finish your practical, you need to submit your lab report. Okay, you have a mark. Okay, your lab report. You need to show your teamwork, your skill, your teamwork have a mark. Okay, so don't play around. Okay, next, report any accident. Okay, split or breakage. Okay, or injured. Okay, cut or burn to the lecturer or lecturologist immediately. Okay, please. So be careful during the practical when you handle, especially when you're handling the chemicals or the beaker. Next, housekeeping rule. Okay, state the reason. Okay, state the reason of being late to the lecturer before going to the group. Yes, if you are late, please let your lecturer know what happened to you. Give the valid reason to your lecturer. Okay, before join the group to start your experiment, to do your experiment. Next, student must grade and respect the lab technology as all the time. Okay, student who fail to attend any of the practical class actually will not be entertained. Okay, except you have a valid reason or you have an emergency. Tell your lecturer first. Okay, group members should display teamwork in the experiment. Yes, you need to show the teamwork. You may have a group, you may have a member of group more than 2, or you have 3 members in your group, so you need to show the teamwork. Everyone need to contribute to do your experiment together, to collect the data together, to connect apparatus together and everything together. And also if you want, and also when you want to do your practical report. Okay, next, ask permission from the lecturer for any reason. Example, toilet, meeting with the assistant director, other lecturer, or vice, or you have a performance rehearsal. Okay. Next, any of the glassware breaks during the experiment, the whole group should be responsible and compensate by paying the cost of the glassware. Yes, you need to pay. Okay, if you break the glassware, so whole group should be responsible. Okay, next, make sure the bench top is clean and its surrounding before you and your group leaves the laboratory. Okay, before you go, okay, before you leave the lab, please make sure your bench top is clean. Okay, return everything in the correct place, your apparatus, material. Okay, Next, sign your attendance at the lecturer's table after you finish experiment and before you leave the laboratory. This is when you have a face-to-face practical. Okay, the procedure is at the end of the experiment, at the end of the practical, you need to submit your lab report. Okay, after you submit your lab report, okay, in lecturer table, okay, then you need to sign your attendance. Okay, you must sign your attendance. The attendance is very important. Okay, then after that you can go. Okay, late submission of the report after the submission dates mark will deducted. Okay, so usually for the practical report you need to submit at the end of the experiment, at the end of the class. Okay, so if you are late submission, so the marks will be deducted. Okay, is it okay or not? Okay, assignment, so plot the data given and draw the graph of baseline fitting and smooth curve. Okay, for today you need to submit 4 graph. Okay, submit 4 graph by today before 11:55 p.m. Okay, you can get the material, you can get the question, you can get the data. Okay, to plot the graph in the LMS under the assignment for this subject, which is you have a subject and then you have a part which is physics part. So get the assignment under the physics part. Okay, upload the question. Download the question. Okay, then draw the graph on the graph paper. Okay, if you don't have a graph paper, okay, you can download from the internet, okay, from the apps of the graph. Okay, okay, if you have a question, if you need to try first. Okay, after finish this, after finish watch this video, please continue with the assignment. Okay, draw 4 graph. Okay, and then if you have a question, if you have a problem, I will give the time. Okay, I will give the live, okay, for question Q&A for this part, for the especially for the assignment, or you have any problem or you have any question from this lecture. Okay, that's all for this. That's all. Thanks for watching this video. Okay, thank you.